Next up, now you've probably heard of competitive gaming, but have you heard of competitive programming? Well, you're about to witness it right now as our experts compete using Visual Studio Code to learn Rust in just 30 minutes. And Asim, it sounds like you have to see it to believe it.
Well, I certainly hope so. We are going to see it right now, and I hope that I believe it or other people can believe it. I can't quite believe I'm trying to do a 30-minute Rust coding challenge. FYI, I don't know any Rust. So luckily, Christina, so please welcome today's competitors, Ryan and Samed. May the games begin. So Samed, why don't you go and introduce yourself? Oh, is he frozen? Ryan, why don't you go ahead? Introduce yourself.
All right, I'll go ahead first. Hi, I'm Ryan. I'm a cloud developer advocate along with Asim, and my focus on a day-to-day basis is the Rust programming language, which we're going to be talking about a bunch today.
Awesome. And Samed, are you back? So let's go.
Oh, no.
Ryan, we're going to be using Visual Studio Code today for our Rust coding challenge. Let's go to your screen right now. And I think you're going to walk us through a little setup, aren't you?
Yes. Let me go ahead and share my screen real quick. All right. So the coding challenge that we're going to be doing today, you can find here on GitHub, and we also have an aka.ms short link for you as well.
The short link is aka.ms/30minute-rust-repo. If you want to follow along and you want to do what Ryan's doing right now, just go to that link, click it, and follow along. Sorry, Ryan, carry on.
Yeah, so this repo right here kind of contains everything that you need to go ahead and get ready with this coding challenge. It's based on another repo that I created as a template here for any Rust-related project, and Rust is the language that we're going to be using today, and we'll talk quite a bit about it as we go through. And the great thing about Visual Studio Code Spaces is that you can create your own environment. And kind of define it in one of these dev container folders that comes with various information on how to set up your environment. And then, it's very easy, very declarative. And then you can come over here onto online.visualstudio.com/environments, and you can create your own code space. And it's very easy. I have one already created here, ready to go for us. But if you want to create your own, it's really easy. Just clicking on this create code space here, and you give your code space some sort of name. So we're going to call this Rust challenge here. Then you have to give it a Git repository of some sort. And so we already have this one set up, ready to go here from our coding challenge from Samed's GitHub. So I'm going to take that and paste it into this Git repository section right here. You can see that it's verified that it's a valid Git repository. And of course, you can pick whatever instance type that you want. We have premium ones if you want to go ahead and do something really challenging and fun. But honestly, the standard or even the basic is oftentimes good enough. And then you pick the idle time that you have, whether you want that to be 5 minutes after being idle for this thing to suspend, 30 minutes or 2 hours. And the best part is once it suspends, all you have to do is go ahead and spin it right back up. And it's really quick and easy to go, and you're up and coding once again. But of course, creation, the very first time, it takes a little time. So I'm going to kick that off right there, and it's going to go ahead and create our coding environment. You can see it running now where it's initializing, and it's going to be running our full Docker container and running all of the initialization that we have to get our coding challenge underway.
And this is brilliant. This is the stuff that we announced, or we went full live with in our keynote today with the Visual Studio Code Spaces, and it's really exciting. I think right now we're just seeing one of the really many benefits of kind of using a platform like this. Has Samed, has he rejoined us right now? No? Okay, Samed, so I understand that we have audio from you right now, and that's really great to hear you. So why don't you just give a quick introduction to yourself?
Hi, my name is Samed. I'm from Palestine. I'm currently pursuing a bachelor degree in computer information systems, and I'm a competitive
competitive programmer. So I met Samed through a program called the Palestinian Internship Program a couple of years ago now. I was mentoring him, and I honestly think it was not even the whole first year. I think he maybe mentioned this thing called competitive programming, but it just never really clicked in my mind. I just kept on thinking it was just something he just goes on a website and just does a few challenges. It was only after the first year of talking to him about it that I realized it's an actual almost Olympic sport. There are people and competitions and leagues of people actually competitively programming with each other all over the world. And Samed's kind of really, really well accomplished in that. And in fact, he teaches other kids now in Palestine competitive programming. Then we had this idea, well, let's combine the two together. Let's learn Rust through competitive programming. And that's kind of where we are today. One of the things I think Samed was describing is that there's a platform called LeetCode where you can get some challenges, and then you basically, that's where you get the challenges, and that's where you can put your code, and you can submit your code, and it can give you the results. I think, Ryan, you might be able to have this on screen for us right now, so you can show LeetCode, I believe. Maybe we can go back to Ryan's screen for a second. There we go.
Yeah, so here I'm showing you LeetCode, and it's a really simple platform. You get some sort of competitive programming challenge, and here's the one that we're going to be doing today. And you get a programming area over here. Now it's not quite as feature rich as having something like Visual Studio Codespaces, but for making quick changes and submitting your code, it's really great. So we're going to be filling in our code right here. We're going to be able to run the code just to check that it's working properly, and then eventually we'll be able to submit it and see how fast is it running, how does it compare to other people's submissions and things like that. It's really a very interesting and fun platform.
Yeah, and let's have a look at the challenge that we're going to try and do today. It's the one on the screen right now, isn't there? Let's try and describe this challenge. I was going to hope that Samed was going to do this for us, but look, it looks like we'll have to explain it. So unfortunately, I didn't quite read it up properly myself. So Ryan, could you explain the challenge to people? Yeah.
Yeah. Luckily, before this, Samed clarified to me what the challenge actually was. So hopefully, I'll be able to do it justice here. Basically, the challenge is given some array of numbers that we have right here. You can see our numbers right here, and let me blow this up a little bit so it's easier to see. We have an array of given numbers, and we want to sum some range inside of there. So sum range 0, 2 here, what that means is give me the sum of numbers in the 0, 1, and 2 inclusive index. So you can see from 0, we go -2, plus 0 is -2, plus 3 is 1, and that's the answer that we end up with. And so our challenge here is to be able to do these sum ranges in as fast amount of time as possible, and hopefully with as little memory as possible as well.
So we're taking just adding some numbers between two indices of an array. That's what we're doing right now. Is it?
Yeah.
Man, that's making me sweat already. Just even doing that in Rust is probably going to be interesting.
Yeah. It's going to be a tough one, but we're going to get through it.
It's going to be, for me, it's going to be tough. I think for you, it's going to be well, we'll see where it's going to be at for you. We'll see. So, so I think that it sounds like if we just need to sum up some numbers between two indices of an array, I would probably just use a for loop and just go through it and add them up. Is that like a good first step?
Yeah, I think that's a good one. We can go back to my screen here, and luckily my environment has booted up. There's one thing that Visual Studio Code is asking me for here, and that's to install the language server that we have. And so let me come in here. And it looks like it should be installed, which is good. So I'm going to open up our file here. And make sure that we are activating our extensions, which should give us code formatting and everything like that. Let's see here. Let me go ahead and
Again, this is
restart
just
it.
all running in the browser, which is still kind of blowing my mind right now. You're running Rust, which
Yeah.
is a compiled language in an editor in the browser.
Yeah, and the whole thing is you get a full kind of environment here. I'm going through, I'm installing, I'm enabling different extensions. It kind of is just like my environment that I have locally on my machine as well. And the best part too is that you can very easily go ahead and install your own dot files, for instance, if you have things that you have personal to your environment that maybe don't come with the environment that you have kind of gone off of, you can very easily put those in as well. And so your environment can be completely customized to the needs that you have.
And like, just for me, I think it's my eyesight. Is there any way we can flip this to a light theme? I know that's a pretty big ask right now, but if we can flip it to a light theme, I think I'll be able to see it a lot clearer myself. And yeah, do you remember how to? I can't remember myself, actually.
Yeah, you have to come in and go into appearance and color theme. And let me see if there's a...
well,
there we go. Is that a bit
developers
better? That's a different thing. I can't say that one is necessarily better, but hey, at least we are up and running.
We're up and running. Let's go for it.
Okay, cool. All right, so we have our code challenge here that we're kind of set up, and as you said earlier, you said you might want to go ahead and do a kind of a simple for loop, a naive for loop for summing these things together. And so we have our sum range here, which is our function that takes our two indices that have been called I and J for us here. And it's important to note here that the indices are I32 types. Now, Rust, we haven't talked a lot about what Rust actually is as a language, but Rust is a very low-level language. It's a language that kind of is in the same space as C and C++. And so you're going to care a lot about these kind of low-level details. But as we'll see, although you have to care a little bit about these details, Rust still gives you a lot of these very interesting high-level concepts that you can work with. We're gonna do a lot of high-level programming. We'll forget maybe a little bit as we go through this that we're working in such a low-level language here, and instead, we'll be doing things that are even high-level coming for you, Seem, as a JavaScript programmer. I think you'll feel right at home, or even a little bit jealous at times of some of the stuff that we'll be looking at today.
Don't get too ahead of yourself there, Ryan. I mean, I'll get excited when I get excited. So that actually looks quite familiar already. So I'm seeing a .rs file. I really know nothing about Rust. I'm seeing a .rs file. I'm seeing fn, which I presume means function sum range. And so you're passing in kind of two integers. And yeah, we just need to sum it up. How do you do like a for each loop or a for of loop in?
Yeah, so in Rust, there's no kind of for loop in the very traditional sense of like a for I equals I plus plus, I less than kind of thing. We're going to do a for in loop here. And so we're going to get some index in the range between I and J. So this is what the range between I and J looks like. So this double dot right here is a range syntax. It basically allows us to say this is a range of numbers between that starts at I and ends at J, exclusive. And so we're not including J in this, which is important to note. So here we have a for loop here. And what we probably want to do is first create some kind of collector, some sum number, and we'll instantiate that to 0.
That looks familiar. I know that's how you declare variables in JavaScript. So that's how you declare variables in Rust, it looks like.
Yeah, yes, exactly. What the thing about Rust, though, is that everything in Rust is immutable by default. And so if we were to try and go in here and do sum plus equals, our numbers, which we don't have our numbers yet. We'll get that in just a second. this index, this wouldn't compile actually, because our sum here is not declared as being mutable. So we need to actually declare it as being mutable, and that's a little bit different than JavaScript, and the fact that in JavaScript, usually by default, everything is mutable, and you can mutate whatever you want, except for in recent versions of JavaScript with something like const. You can think of Rust as kind of preferring const, and you really have to do a little extra work in order to make something mutable then.
So if I was to declare a variable in Rust, by default it's read-only, and I have to put that mut keyword there to make it read-write.
Exactly.
Okay.
So we're writing to this numbers variable here, but we haven't actually instantiated that. And you can see here that we're actually first going to be the LeetCode example will first call this new function and pass in our numbers as a vector, an array, a growable array of these numbers. And so we need to kind of keep track of that. We need to hold that in memory. And so in our struct here, we're going to have declare up here that we're holding on to this vector of I32s. And then inside of our constructor here, our new constructor here, we're going to do the same thing where we basically take the numbers that get passed in there and put them into our struct, just like this. And so now our struct has been instantiated with the numbers that have been passed to us.
So a struct, coming from, I have a background in C++ a long time ago. So a struct is kind of like a class that you have there, and you're kind of instantiating it with an array of numbers coming through. Oh, interesting. Yes.
Yeah. So Rust is not an object-oriented language. It is kind of or I shouldn't say it's not exclusively an object-oriented language. It kind of borrows the best from all different paradigms. So Rust has some things from kind of imperative programming and the C kind of style. It has things from functional programming that you might be used to if you've done things like F# or Lisp or something like that. And it also has things from OO as well. But classes is not one of those things. So we're dealing in structs, which are generally just pieces of data, but they can have functions and methods associated with them here. So what we're seeing here with the new function is a associated function that constructs our type. And this sum range down here is a method. And the reason we know it's a method is because just like in Python, for all you Python fans out there, the first argument in methods is self or this or whatever you'd like to call it, the receiver.
I am an ex-Python person. Yeah, okay, this is all brilliant, so that I can now relate. So yeah, you're passing self as the first parameter to each one. Understood.
Exactly.
Understood. Yeah. So this is it, isn't it? We just return sum or something here, or?
Exactly. And now, you might be tempted if you're coming from some languages to do something like this, where you explicitly return. Well, borrowing from its functional programming side, Rust is definitely a very kind of value and expression oriented language. And so the last value that we have inside of a block is the value of that block as well. So we don't have to explicitly say return here. Sum will be kind of implicitly returned. Now we can do early returns and stuff like that. So there is a return keyword, but here at the end of the method here, we don't have to actually explicitly call return here.
Okay, but from my complete beginner knowledge of Rust right now, it looks like we've got a solution. It looks like we're giving the answer we need. And I believe we have Samed. Samed, I believe you're back now. What do you think of this solution? And you can be critical. Ryan can take it. How would this solution compare in your competitive programming world?
So this solution will work. But the problem is every time you're going to call the sum range, if you're going to call it a lot of time, it's going to take a lot of time, right? So the complexity of this solution is O of n. And it's going to take a lot of time. if we're gonna call some range over and over again. So can we do better? Let's first try to submit the solution on LeetCode and see what it would give us.
Yeah. So Ryan, I think you can actually copy and paste that code into the LeetCode browser, hit submit, and let's see what score Ryan gets. We're going to get a drum roll, I think.
So I'm going to come over here and paste in our code. Now, I know for a fact that we have one final thing to do to get this to compile here. And that is that I and J here, as we've said, are I32s. They're 32-bit integers, but you cannot index into collections with I32s. You have to index into collections with a type called usize. And again, this is kind of Rust being a very low-level language. Usize are any variable or a number that is the size of pointers on the machine. So if you're on a 32-bit machine, usize will be 32 bits big, and if you're on a 64 machine, it will be 64 bits big. Now this should make sense if you think about it, because I can't index into an array that's bigger than the index is bigger than the maximum 32-bit integer on a 32-bit machine. Numbers don't go that big on those types of machines. And so Rust really cares, how big a number actually is. But I think with that little change right there, we should be able to run our code.
And you've just blown my mind a little bit there, because I remember my days as a C++ programmer, and I'd always get caught out with you'd build on a 32-bit machine, or you build on a 64-bit machine, you run a 32-bit machine, and you're always getting mistakes with the types of pointers. This is one of the features of Rust, isn't it? It's kind of this safety feature when you're programming it. It sounds like usize is kind of one of those features. Does that sound about right?
Yeah, so Rust is very much oriented towards being a language that cares about correctness and safety, and that's a reason that we actually here at Microsoft are very interested in this language. And I'll be giving a session tomorrow about our safe systems programming languages effort that we have here at Microsoft. And one piece of that effort is to adopt Rust exactly for its safety properties, for the property of being able to write correct software. And in fact,
awesome.
It's so correct here that we're getting a compiler complaining about us. It doesn't know what this numbers is here. That's because there's no implicit call to this, like there is in some languages like C++. You have to do self dot here. And so now I'm really hopeful here that this is going to actually run correctly. And oh no, we got the wrong answer. So Rust doesn't protect you from every single programming mistake, right? That's unfortunate. And it comes back to the problem that we have here comes back to something that I mentioned before, where this dot range here is an exclusive range, but we want everything between I and J inclusively. And so we have a different syntax for that. Instead of doing an exclusive range, an inclusive range is just like that. I to J, including J. And I think now not only will it compile, but we'll also get the correct answer here. At least I'm hoping so. Okay, it's accepted. So we know we have the correct answer here. Run code, by the way, here is just going to show us that our answer is accepted, that it's correct. But once we hit submit, we'll be able to actually run it and see how fast it is.
Are we going to do that now, or we'll do that later? Because I think Samed is still. I think Samed is still. There's still some criticism to do with this guy. What's your thoughts on the code so far?
So my thoughts are that as we see, the sum range will be called a lot of times, and every time you're gonna call the sum range function, it's gonna cost us O of n of time complexity, and that will cost us a lot of time. So in competitive programming, we try to make our solution as optimal as we can in time and sometimes memory. It depends on if you want to trade time by memory, or you just trying to make it faster, right? So in this case, this code will work and it will give accepted, but it's going to take a lot of time. And in this case, I think we can do better than this. I think we can actually take out the sum, return the sum between two indices in O of 1 instead of O of n, which is a huge difference.
Mm. Wow. That's like is that constant time, isn't it? Is that?
Yeah.
Yeah,
Exactly.
a long time since I've done this kind of complexity analysis. So, what are some suggestions?
So one of the ways we can do it is we can make another array that has the cumulative sum of the original array. So if you have the input array, the original array as 1 to 4, let's say, so we're gonna have another array that we're gonna store the sum, the first element will take the sum from 0 to the first element, which is just one element. So our first element is gonna be 1. And the second element is going to be the first element plus the second element. So that is 3. So our array will look like 1, 3. And for the last element, we're going to add the 4. So at the end, we're going to have our cumulative array as 1, 3, 7. And what we do to return the sum of 1 is we take a sub-array of the cumulative array. We take a chunk. So what we do is we return the jth position, the difference between the jth position and I minus 1 position. And this way we can take the chunk of the sum and return it in constant.
Very sneaky, I see. So you're kind of doing a little bit of pre-calculation to create almost like a cheat array with everything kind of pre-calculated to a certain degree. Then you're doing some nice little maths to kind of always get the answer like really quickly by just doing essentially a lookup and one operation instead of kind of looping through everything in one go. Does that sound like a simplistic explanation of what you described? I finally get it. I get it. Awesome. So Ryan, can you rustify that? Can you go for it?
Yeah, I think so. So let's see. The first thing Sumedh mentioned was going through and calculating the cumulative sums at each position. And so what I'm going to do is another for loop, and we'll say for n in numbers, and we're going to get a mutable iterator into our numbers vector, and that will allow us to actually mutate the numbers as we go along. And I'm going to keep track of our sum as we're going. So our sum here is going to start out as 0, like we have here. And the first thing that I'm going to do is change the sum by the first element, or each element in the array. So sum is equal to plus equal n here. Now we got to remember to make sure that our sum is mutable. And because we have a reference into our number here, we're going to have to dereference it. This is Rust again being a low-level programming language, and we're dealing with pointers here, so we have to dereference. You'll have to remember that from your time doing C or C++. And the final thing that we're doing is, again, it's everything is immutable by default, so we have to say that we're going to be mutating our numbers as they come in. And so we've got our sum, and we're going to write to n with our sum. So now n is equal to the sum as we go along. And that should do it. We now have our cumulative array here. Every element is equal to the preceding elements added up all together. And so what we're going to do is we're going to get the top half is going to be self.numbers. We're going to get the jth element here. And let me just go ahead and do this. So we're going to get our jth element here, and we have to index into it with usize, because again, Rust cares about this stuff. And then the bottom half here is going to be self.numbers at the ith index, as usize here. All right. Now this isn't quite right. Well, we could try this, but it won't be the correct answer, because we don't want jth element minus the ith element. We want the jth element minus the I minus 1 element.
Right.
Yeah, makes sense.
Now, if we go ahead and do minus 1 like this here, what happens when I is 0 is it will blow up, because we're trying to we're wrapping around. we're going below 0 here, which is
because it's an
which is not something.
unsigned. It's an unsigned. It can't be a negative number because you said it can't be a negative number. Yep.
Exactly. So we need to go ahead and say something like if I here equals 0, we'll do one thing, and otherwise we'll do another thing. So if I is not 0, then we're just going to go ahead and do I minus 1, like before. But if I is 0, then we're just going to return 0. And notice here I'm assigning from an if expression here. So Rust allows us to do that, where we assign from an if expression. And in fact, for the functional programmers out there, I'm just going to quickly show you have pattern matching as well, which is, if you're not used to functional programming, this might seem a bit different to you. You can basically think of pattern matching as switch statements, kind of very fancy switch statements. And so this is to please all the Rust programmers and all the functional programmers out there that we can write it. This is exactly equivalent to what we had before. And so I believe that I'm hoping that this will do it. So let's go ahead and see if the code runs.
The tension at the moment right now.
What's
it going to do? It's worked. Okay, well done.
That's good. So I guess maybe we should go ahead and submit this thing to see how well we've done. What do you think?
Yeah, I'm interested to know how good a Rust programmer you actually are, Ryan. Let's get your score.
All right, I'm going to hit submit here, and we'll see what kind of results we end up getting. And it takes a little bit, but cool. There we go. So we've got success. It runs in 4 milliseconds, and apparently it's faster than 100% of the Rust Online submissions. So it turns out I'm a pretty good Rust programmer, I guess.
Well, I hope so. That's fantastic. Well done, Ryan and Sumedh. How does that? So is that the kind of answer you would have expected? That's the kind of optimal answer.
Looks great. This is how exactly. This is one of the ways that we can actually solve the problem in an optimal solution. Good job, Ryan.
Yeah, great job, Ryan. And I'm really glad I've got to say I've learned a lot today. I actually really did know nothing about Rust. I made sure I didn't really research at all, and I was really interested to see if I could learn a bit about competitive programming, but B, I could learn Rust. And I definitely learned a lot about Rust. I was very surprised at how much I learned. I learned a lot in a really short period of time. Thank you so much, Ryan and Sumedh, for your time today. Now let's take a few minutes to check in back at the Build Live desk in Redmond.
Asim, I think you have something there with competitive programming, and I'm with you. Like, I've never really been a big Rust person, but thanks to Ryan and Sumedh, I feel like I know a lot more now. But now